Hi everyone. This is a video that will accompany an assignment that we either did in class or weren't able to do in class, or you're absent and you missed it. So it's going to be a longer video than usual because I'm actually going through the assignment. So at this point, you need to get your assignment, download it from Blackboard, or you should already have it in your composition notebook. You're going to need a pencil, of course, to do the assignment, and then a calculator. My suggestion is that you have these things together, that you're working them together as you begin to catch on to the concepts. Stop the video and try working the problems yourself. And then I'll put the answers on here and we can work it as a lesson that we would have done in class. All right, so let's get started. All right, so this is the assignment, and what I've given you are 6 graphs labeled A through F. We're going to go through each one of them and do 2 things. We are going to shade the region that it says to shade, so you can see A and B there on your screen. We're going to shade between the curve and the x-axis on A, between the curve and y equals 0, which is also the x-axis. And then we're going to set it up so that we can find the area of the shaded region and then use a calculator to find the answer. Okay, because we're not going to integrate them by hand. But all of these areas are formed on the idea that an area that is above the curve, above the x-axis, is positive, and the one that's below the x-axis is negative. But remember, area is positive in real life. We don't have negative areas. We don't have negative distances. We always walk in a positive direction starting at t equals 0. So what we're going to do is look at the shading. So you can kind of see I've already shaded here. The other thing that's really, really important is that you note that the curve and the x-axis, there are 3 intersection points. And those are important, where the 2 things intersect, where the curves intersect. Those are really important, plus the area itself. So one thing that you could see is that if you find the area under the curve, like all under the curve. So I'm trying to figure out the best way to show you this, but all of this would be under the curve, right? And then subtract from it just the part that's under the second curve, the bottom curve, then what you would be left with is the area. So this is the idea of top minus bottom, okay? So if we wrote that out as an integral, because we're trying to find the area, right? So I would have the integral, and then my top function, I'm going to write a t here, just this part right here, and that's the bottom. So I'm going from -2 to 0 only, right? Where the top is the function that's given, which is x to the third minus 4x, minus the bottom, which is y equals 0. And that gives me that area. Now, if you're paying attention, you kind of see that those 2 areas are probably the same. They're the same areas, right? So I could literally just stop, put a 2 here, and that would give me area. But let's go ahead and set up this bottom one, because on the rest of it, note that you need the graph so that you can see that it changes. The top and the bottom are separate. So if I were doing the bottom, right, I would go from 0 to 2, and then I would have 0 minus, and I'm going to put the function in parentheses because that minus sign is going to distribute, right? And so what happens there? Well, it's below, but what did I put in front of it? A minus, which means it's going to be negative, negative, which is positive. So this is actually going to get me the area, positive area, because I've done top minus bottom. Now, once again, I could put a 2 in front of it, and or I could just add this top one and the bottom one together and get the same thing. So if you put that in your calculator, remember you're going to use Math 9, right? And it comes out looking like that, and you're putting stuff in here and then here, you know, you've got to do all that. And so you're putting the numbers in. Hopefully you remember how to do that. On this one, the area is going to be 8. Okay, on this one, it's a little simpler. So I'm going to go ahead and shade the area between the curve and the line y equals 0, which is still the x-axis. Okay, it doesn't have to be the x-axis, but it is on this problem. So y equals 0. Okay, and so I'm going to note that I have an intersection point here and an intersection point here. And so for simplicity, they gave us pretty easy points. So I'm going to go from -2 to 2. My function is negative x squared minus 4, or sorry, plus 4 minus 0 dx. So top, bottom, top minus bottom. Now, I could also, you could have split this up. You're starting to see the scheme, right? So -2 to 0, just do 2 of those and do minus 0 dx, and you're going to get the same thing. These will be the same thing. And the answer is 32 over 3, 10 and 2/3. So on curve C, it says find the area of the curve in quadrant 1. So same kind of deal. It's still talking about shading, right? So here I've got this shading going on. And once again, intersection points. Okay, this is the top, this is the bottom. And so if you want to stop the video right now and see if you can set up the integral yourself, okay? I'm going to keep it going. So I'm going to go from 0 to 4. The top is the curve. The curve is 4x minus x squared minus 0 dx. And that's going to get me, once again, 32/3 because it's the same function, it's just moved over. So on this one, it's talking about shading it, the curve in between the curve, the x-axis, and the y-axis. So x-axis is x equals 0. The y-axis, sorry, the x-axis is y equals 0. The y-axis is x equals 0. And so I want this piece right in here. And so this one is a little more interesting because it brings up the idea that you could also find the area between this curve and the y-axis. So what I'm meaning by this is to set this up normally, right, using the x-axis, you would just do the integral from 0 to 4, right? We could see it intersects here and here. This is top and this is bottom, right? So you're doing top minus bottom dx. So the function on D is the square root of 4 minus x minus 0 dx. Okay, and that'll be perfectly fine. That will get you an answer. But on this one, I'd like for you to see it from a different point of view. I would like for you to see it, get this to work, for the y-axis, right? So you still got this function over this function. So this is right and this is left. So another way to set this up would be dy. And so it would be right minus left. Well, the left is just 0, right? So I'm going to put that in there. But it's dy. So these numbers on the integral are going to be 0 to 2, not 0 to 4. And then this function in here needs to be in terms of y, because you're integrating it in terms of y instead of x. So, okay, how on earth do you get that? Well, I've got y equals the square root of 4 minus x. So what I need to do is solve for y. So I'm going to square both sides. That gets me y squared equals 4 minus x. I'm going to move the x to the left and the y squared to the right. So don't freak out too much. 4 minus y squared, right? So this is what I'm going to put here instead. And believe it or not, the answer is still going to be 16/3 because I'm only integrating this y squared function is a sideways parabola, right? But I'm really only integrating from 0 to 2. So I get the same area. So that's a really interesting one. And the only reason I would do right minus left is if you can't, or it's too complicated to do top minus bottom. Top minus bottom, you have to split it, but right minus left, you don't. A lot of times that's easier. But most of the time, you're going to use top minus bottom, but you need to know how to use the other as well. Okay, so curve E is that same square root function, but it is moved left. So we are now in the second quadrant. So we're trying to then shade the area in the second quadrant, which would be this right here, right? So this would be the curve, the y-axis, and the x-axis, only they're talking about it in second quadrant. And then once again, here we go, we have these two intersection points. All right. Do you see that on this one as well, you could set it up as right minus left? This is top minus bottom. But you could also do, change color, right minus left. There, right minus left. I'm having fun with the pens today, evidently. Okay, so let's just, it looks like top minus bottom would be the easiest. I don't have to solve for x. I don't have to do any of that. So I'm going to do the integral symbol from -4 to 0. And then I am going to do the square root of x plus 4. That's the top curve minus the bottom curve, dx. All right. And then if you wanted to figure out what it would be right minus left, I will tell you this, it's going to be 0 minus something, and then dy. And it would be from 0 to 2. And you should get the same answer. And the answer that I got for this one was 16/3. And I'm watching my key very closely. I'm trying not to make any errors whatsoever. Okay, so the final example on this sheet is F, right? And so this one I want the curve and the x-axis. I'm going to do some shading. You notice that this is below, that the area is going to be positive. So there's my shape. And I'm going to write in, here are my intersection points. Notice that I could split it up, right? I could just do half of it. Once you know the graph, that makes that just a little bit easier. I think I'm just going to do the whole thing. So this is top minus bottom, right? And so I'm going to do the integral from -2 to 2 of the top, which is 0, minus the bottom. And the bottom is x squared minus 4. Now notice I put that in parentheses because the negative has to be distributed or moved out. You could move it out to the front. That would be just the same. And then doing that would get you 32/3. Familiar numbers, aren't they? Aren't they? Yeah. Okay, so be sure that you know that the area is always positive. It's going to be top minus bottom or right minus left. Right minus left is dy. Top minus bottom is dx. Be sure to distribute the negative. Train your eyes to see the top and the bottom and the right and the left. it seems like we're always looking at graphs, and so it's really good to be able to sketch a graph quickly and easily, especially using transformations. That would make that easier. Okay, so that's it for these. This is what we would have done in class. I probably haven't remembered to tell you everything, so join me on the next screen for the laundry list. Okay, so this is a really important thing that you need to have in your composition notebook. And I put copies of the completed laundry list in Blackboard. I've split it up into 3 pieces. So this entire unit, area under a curve, area between curves, cross sections, revolution of solids, all of that belongs on a laundry list. And so the laundry list is just a list of concepts to help you understand. It's all in one place. It's one of the best things I've ever seen. And so we're going to start the laundry list today with this area under a curve. And so start your laundry list and title this area under a curve. And then we're drawing a graph. You can see my curve on here called f of x, right? And we're going to divide the area under the curve here. This will be A, this will be B, right? So we're going to find the area between the curve and the x-axis from A to B, right? And so we're going to divide that. Remember Riemann sums. We're going to divide this area into rectangles, right? And then we're going to take the limit of those rectangles, and then that's going to give us the integral, which is the exact area under the curve between A and B, right? So one of these rectangles has a width, and this width is delta x. That's the width. That's the one that gets smaller and smaller and smaller and smaller. Remember the dx in the integral. And we find the width of delta x by taking b minus a and then dividing it by the number of rectangles. That's what n is, the number of rectangles. Okay? So this first concept that we have of area under the curve is, and I'm just going to say the area is approximately, and it's approximately adding the area of the rectangles. Okay, and another notation that we used to add was this symbol that says the same thing, add up the area of the rectangles. Okay, still approximately. The area of a rectangle is made up of its height times its width. And then we're going to get more specific. We're going to say, we're going to let I equals 1 to n. The height is going to be the f value at each x coordinate, x sub I, times the width, which is delta x. All right? And then to get the actual area, now I'm to equal, I'm going to take the limit as n approaches infinity of the sum from I equals 1 to n of all the heights times all the widths. So the area is going to equal the integral from a to b of f of x dx. And that's going to get me the area under a curve, right? This is area. So from a to b. So area under the curve and the x. This is net accumulation. Net accumulation. So that's area under a curve. So the second part of the laundry list is this idea of area between two curves. So it's slightly different because you're talking about both curves are separate. They're not an axis. They're not the X or Y axis. But we still have a top and we have a bottom. We still have the top curve and the bottom curve, and we have intersection points. So we've called this because all of one is over and all of that is on the bottom. If you look at this one down here, and I do want you to copy these onto your laundry list, you see that you have, if you were doing top minus bottom, here, this is top and bottom. Can't use top minus bottom on this particular graph. But we can use right minus left. And notice this is f of y and g of y. They're not in terms of x. This one is in terms of y. All right? So if we're writing with our laundry list, the area is going to be approximately the sum of the areas of rectangles below the top minus the sum of the areas of the rectangles below the bottom. And so what's between then would be this. So it's this idea that you are finding the area below f of x, all of it, and then you're subtracting from it the area below g of x. And then what you're left with is this in between. And that's what you're after. Okay? So once again, you're still going to have all of the limit notation that we had before, but eventually you will end up with the exact area, which is going to be the area from A to B of f of x, right? Everything below the bottom minus that same area of the bottom function, which written together would be a to b of, you're using the property of integrals to write them all as 1 dx. So this is top minus bottom. Now, that's what we were doing even when one of them was an axis, right? We just put 0 minus or something minus 0. This one you would actually have two functions. So what does this bottom one look like if it's f of y, right? So the area of this one would be an integral from c to d of g of y minus f of y dy. And this is right minus left, right minus left. Okay? So this is your laundry list. This is what you can go back to and you can look at and see how they got this concept and how they write it. And you'll notice that I'm using little shortcuts like top minus bottom, right minus left to help me remember which direction that I'm doing. And as always, these are simple concepts, but get the simple things down because we're going to add to it. So learn the simple so that when we add to it, it doesn't seem exponentially harder. Okay? I know this was long. I hope it was helpful. And hopefully I will see you in class. But at the time I'm making this is during the great pandemic of 2020. And so we are not in school. So I'm hoping everyone is well and that you find this helpful and useful. And I hope to speak with you soon. Bye, all. Be well.